Let's now add some very simple interactivity to the application for the very first time by building a counter client component. So, first of all, let me show you that we actually really can't use React hooks here in a server component. So again, we know that this is a server component. And so if we tried to call useState here, then let's see, you're importing a component that needs useState. It only works in a client component. But none of its parents are marked with useClient, so they're a server component by default. So exactly what we learned 2 lectures ago, right? And so we need to get rid of this and of this. So we're not allowed to even import useState into this function. And so let's create ourselves a new counter in a new component right here. So counter.js. So export default function counter. So let's say count and set count. So the very, very standard counter. Let's say we start with 0. And now watch what happens as we try to import that counter here. So let's do this after. So exactly, we get the exact same error. And so that's once again because by default, this is a server component. So let's now use that directive that we learned about earlier for the very first time. So in order to declare this component as a client component. So use client, and that's it. That will fix all our problems. So now let's return a simple button here, because now we are finally able to do that. So having something that has some interactivity. So here we have the current count, and then just the onClick handler, and set count. Then we grab the current count and add 1. Okay, there is that button, and it works. Great. So we have our first interactive piece on or in our application. And now I want to show you, just like before, that there is actually hydration involved here. So if we load this page really slow again, maybe even slow 3G, so then as we expect, the static HTML will be downloaded. So then nothing works as we click here. So in the background, the React bundle is now being downloaded. And once that kicks in, then the whole page will be hydrated, meaning that the event handlers will be added back and all the interactivity will be added back. So it's still loading, so probably it's still not going to work, but at least the user is able to see all this important content already. So many times that's the most important thing on a web page or a website. And so then this is actually a pretty good solution. So this button doesn't work, or now actually it does work, but in the beginning it didn't. But yeah, again, at least the user could see the most important information already. And then after everything has finished loading and the React bundle has been downloaded, then this button became interactive. Great. So let's put that back. And now another thing that I want to show you is to cross the server-client bridge with some data. So as we also talked about in that lecture about server components. So remember how one thing that we can do when we want some data on the front end is to fetch it in a server component and then pass it as a prop to a client component. And so then these props between a server and a client component basically acts as a bridge over the server-client boundary. So let's say that here, this counter actually accepts a prop of users, which is not really related, but that's not the point. This is all just a demo here, really. So we're even going to delete all of this here later. or actually this is called data. And so now, if we are here back on our client component, we can log that here. So if we now log this again, so the same data, this time it's not going to show up here, but really down here. And indeed, there it is. So we're no longer logging it on the server. That's why nothing is here. But now this exact data has actually reached the client and has been logged to the console there. Of course, we can also do something with that data here, just to make it just a bit more meaningful. Let's say there are, and then users dot length users. And so if we save this, then indeed we get there are 10 users rendered here on the client with the data that was just received. Now, if we set this again to slow, just to show you one final thing, then now it's loading the data. So the interactivity is still not here, but we are for some reason already seeing the output here of the component. So this client component. The reason for that is that on the initial render, actually all the components are first rendered on the client and then sent as HTML to the client. I'm not sure if I said it right, but so what I wanted to say is that all the components are rendered on the server on the initial render, no matter if it's a server or a client component. Okay, so that's just a preview of one of the most important topics that we're going to learn by the end of this section, which is how server-side rendering actually relates to React server components. But here we already have the practical effect that this string right here was rendered on the server, and we could see it here immediately, even though the React bundle, which contains this client component, was still being downloaded. All right, so just remember that for later, once we talk about the relationship between React server components and server-side rendering. Okay, and that's actually all I had to show you in this lecture. So this is all just an overview, and we're going to come back to this interaction between server and client components many times throughout this project. So this is just a preview, and so this is more than enough for this lecture right here. So see you in the next one. There's just one more cool thing that I want to show you before we wrap up this introductory section, which is how we can easily display a loading indicator whenever one of the pages loads some data. So here we are back in our cabins page, which is the one that right now is fetching this user's data. And so remember how whenever we go to this page, it actually takes some time to load or to render. So notice that I clicked here and then there was a slight delay of like a second, and then this content here was rendered. But that's of course not an ideal experience for our users, especially if it took even longer to load this data. So if we had more than just these 10 data points here. And so while this data is loading, we should probably add some loading indicator here. So like a loading spinner or something like that. And that is actually very easy to do in Next.js because there's yet another convention, so another file that we can create, which is called loading.js. So right here in the app folder again, so here in the root level, close to this page and this global layout, we will create a global loading file. So loading.js. And I said that this is a global loader because this one will actually apply to any page that is in our application. So even if it's some route that is deeply nested, like cabins/test/23, so even if that page would be loading some data, this loading indicator that we're going to build here will then be displayed. All right. So as always, this needs to be some component. So export default function, and here let's just call it loading, even though the name of this component does not matter again. And then here, let's actually go to our starter files, because here we already have a loader. Well, actually that loader is not going to work yet because we don't have our styles applied. So let's do that later. So let's just return like a paragraph here, which says something like this. So loading data. Okay, and that's actually all we have to do. So if we now reload the page, let's see what happens. So you saw that like for this 1 second, here it said loading data. So only for the page content itself. Everything that's in the layout, so this navigation here and also the footer, was shown instantly. So basically the way this works is that with the loading file, we can display an instant loading state that will be immediately rendered on the server while the content of a route loads. And so then as soon as that content has been loaded, it will automatically get swapped in once it has arrived. So let's take a look at that again. And so notice again how the part here that is part of the layout will be rendered immediately, and then that loading data part will be shown for a second there, and then this part here comes in as well. Now behind the scenes, this loading.js file actually activates streaming. So basically this data right here will be streamed from the server to the client automatically and not sent in one go. So remember how earlier in that small experiment that we did, we used the render to string function from the React DOM package in order to render our React code, so our React components, to an HTML string. However, that is not how Next.js does it. Instead, they use a similar function that is also part of React DOM, but which supports streaming. And that one is called render to readable stream. And so again, behind the scenes, that is what Next.js uses in order to power this. Now, this feature actually needs JavaScript to be enabled in the browser. And so that means that streaming will not work when the user has JavaScript disabled. So if you want that your website works without JavaScript, then you cannot have any loading.js files in your application. All right. Now, finally, I just want to mention that we can also activate streaming for individual components using suspense. So this here now works for the entire page, even if one page had like 20 components in there and only one of them would be fetching data. So then the whole page basically would be replaced by the loading state initially. So if we don't want that and want a more granular approach, then we would have to use suspense for that. But again, more about that later, because that's actually something that we'll need later in our project. Okay, but if all we need is just a simple loading indicator that just works easily out of the box for our entire application, all we have to do is to create this one simple file following this Next.js convention, throw some loader in here, and that's it. So very, very easy once again. And as I said, initially, this will actually work for all the subroutes as well. No matter how deep the page that is loading data or even a component that is loading data is in the URL structure. All right, and with this, we finished the practice part of this introductory section. Now to finish, all we're going to do is to just look behind the scenes of how React server components actually work and how they are actually rendered. So those are going to be two very, very interesting lectures that are coming up next. To finish this section, let's now dive really deep into how the RSC architecture actually works behind the scenes. Now, if all you want is to just be able to use server components like we've been doing, then you can safely skip this lecture. But if you like to know how stuff actually works, like the videos in the earlier section on how React works behind the scenes, then this video is for you. And let's actually start with a quick and very simple review of what we learned in that earlier section, and in particular, how rendering works in traditional React, so in a world without React server components. So it all starts with us writing some components, like these components A, B, and C right here. Then, as we compose these components together into a user interface, we end up with a tree of component instances, which is simply called a component tree in React. So here we have one or more instances of each of the components A, B, and C that we've written earlier. Then, next up, it's time to render this component tree. And remember that rendering in React simply means to call each component function. Now, the result of calling a component function is a React element, which is simply a JavaScript object that contains all the information necessary to create DOM elements for the corresponding component instance. And so, as a result of rendering, we end up with the React element tree, which we can also call the virtual DOM. And it's this virtual DOM which will then be committed to the actual DOM by creating all the necessary DOM elements to represent the different elements in the React element tree. And this is how, in simple terms, the components we write become HTML elements visible on the screen as UIs. Now, we didn't include re-rendering, diffing, reconciliation, and all those confusing terms here because they won't be needed in this lecture. This is just a review anyway. But it's important to remember how rendering works. So basically this part right here, because then we can think about how this will actually work when we add server components to the mix in the new RSC paradigm. And so that's what the rest of this lecture is all about. So let's say that we have an app that uses the RSC architecture and that we have this component tree, which contains both server component instances, which we'll call SC in this slide, and client component instances, so CC for short. And just like before, I'll keep it simple by usually just saying component instead of component instance. Now, the idea of this slide is to learn how and where server and client component instances are rendered step by step. So when React encounters a tree like this, the first thing that's gonna happen is that all server components are rendered, of course, on the server. And as we just saw in the previous slide, rendering a component simply results in a React element. Now, each of these React elements really just contains the output of the server component. So they only contain information on how the DOM for each component will look like, but they no longer contain the code itself that was necessary to render each component. So effectively, the code from the server component has disappeared right on the server. But why does that matter? Well, this right here is the technical reason why we can't use state in server components. It's because functions like useState or useEffect would just disappear as the component is rendered. And it needs to be this way because these React elements have to be sent to the client later, and so the whole thing needs to be serializable, which functions are not, as we learned earlier. Therefore, there is no way to send functions like useState to the browser, and there would also be no way of even keeping track of state, because we also have no fiber tree here on the server, and even if we had one, we couldn't send it to the client anyway. But anyway, back to our topic of rendering, you might be thinking, what about the client components? Well, what happens to client components is actually extremely interesting. So, since we're still on the server, this is not where client components are gonna be rendered. Instead, we can imagine that this component tree contains a placeholder, so like a hole in the place where each client component will eventually be rendered. And each of these placeholders or holes contains the serialized props that might have been passed from a server component to the current client component, plus the URL to the script that contains the actual component code. And this reference to the code is necessary so that the client component can later be executed on the client. So it can be rendered on the client. Now, creating the script with the component code and the URL pointing to it is something pretty complex that must be powered by the bundler that the framework is using, and not by React itself. And so this is just one more reason why it's almost impossible for us to implement RSC ourselves without a framework. But anyway, again, client components won't be rendered on the server, and therefore we need a way to pass them onto the client. And what information is necessary for that? Well, exactly what we just described. First, the props that they received, and second, the code to actually run the components on the client. And so that's exactly what each of these placeholders will contain. Okay, so at the end of this first step, we have this weird tree that is a mix of executed and unexecuted component instances, which we call the RSC payload. So this payload is essentially the virtual DOM of all server components, since these have already been rendered, plus some subtrees of unrendered client components. Now, this is called the RSC payload because it's this data structure that will be sent to the client in the next step. And by the way, this is what the RSC payload that the client receives looks like. So it's basically this tree, but transformed to a JSON-like data structure. So something that looks a bit like JSON, but is not exactly JSON. It's actually a data format that the React team came up with that is, again, like JSON, but split into multiple rows so that it's easy to stream this data from server to client. So this code here is kind of a mess because it's actually a real-world piece of data, but if we look closely at it, we can see some interesting things. For example, these two lines clearly look like some representation of DOM elements being sent. And so these are some React elements. And notice how it's all strings, meaning that everything has been serialized in fact. Then here we have URLs to some scripts, which are part of these imaginary placeholders for each client component. And so here we have basically proof that React sends all this stuff from server to client. Now, speaking of server and client, notice how we have these React icons here. And the reason for that is that these are actually not the server and client in the typical sense of a web server and a browser, but really a React server and a React client. But more about this in the next lecture, where we talk about how RSC relates to server-side rendering, because they're actually not the same thing. But now, moving on to the next step and to the client, this is where the client components are finally rendered as well, also resulting in new React elements. And with this, we now have the complete final virtual DOM on the client ready to be committed to the DOM in the usual way that we already know of. All right, so looking at this diagram, if we think about it, rendering in RSC is actually pretty similar to rendering in traditional React, but simply done in two steps and in two different environments, so the server and the client. We start with a component tree as always, and in the end, we have a tree of React elements generated in two steps. Now, we're going to summarize this whole thing in a moment, but for now, let's just ask ourselves the question, why do we need such a complex process with this RSC payload? Why not just render server components as HTML and send that HTML to the browser? Well, the fundamental reason is that React really wants to always describe the UI as data and not as already finished HTML. That's the whole reason why data structures like the virtual DOM and the fiber tree exist in the first place. Now, in the case of RSC, representing the UI as data even on the server gives React the ability to correctly react to re-renders of server components. So what this means is that whenever a server component re-renders and produces a new React element, that element can basically be merged seamlessly into the already existing virtual DOM on the client. So again, when a server component is re-rendered, a new RSC payload is generated and sent to the client, where React can then reconcile the current tree on the client with the new tree that's coming from the server. So according to the mechanisms that we learned earlier in the course in the section on how React works behind the scenes. Being able to reconcile a new tree with an existing tree on re-render is really what React is all about at its core. And so this core idea should also work with server components. And it's actually extremely important that this works correctly because it allows React to preserve UI state as a new tree comes in from the server. If instead just HTML would be sent, the entire UI would have to be replaced with that new HTML and all current UI state would be lost, leaving the user with a pretty bad and jarring experience. So, to avoid that, the React team came up with this two-step rendering mechanism and the concept of the RSC payload, which I think is a pretty genius idea. Alright, and now to summarize and consolidate all we just learned, let's go back again to how rendering works in traditional React and compare it with rendering in RSC. And I believe this will be pretty helpful. So in traditional React, it's all very simple. A component tree is simply rendered to the virtual DOM, which is then committed to the real DOM, which results in a bunch of DOM elements representing the original component instance tree. On the other hand, in React with React Server Components, we also start with a component tree, but a tree that usually has both server and client components and is located on the server. Now, in the RSC architecture, the render process is split into two steps, where the first step is to render only server components. The result of this is a virtual DOM of these already rendered server components plus the unrendered subtrees of client components. So server components are rendered and client components are not, and they both exist in the same data structure, which we call the RSC payload. Now, in this RSC payload, there is some information for each client component that is essential for React to render these components on the client later. So for each client component, the RSC payload has a placeholder or a hole where the client component will render later, the serialized props passed from a parent server component, if that's the case, and finally, the URL pointing to the script that contains the component code. Again, this is the data that React will need on the client in order to render each client component. And speaking of the client, that's where the RSC payload will travel next. So both the executed server components and unexecuted client components are now on the client, which brings us to step 2 of the rendering process. And from now on, the process is basically identical to traditional React. So in step 2, it's time to now also render the client components. As a result, React will now have the complete virtual DOM ready to be committed to the actual DOM. So again, these last steps are exactly the same as in traditional React. And in fact, the entire process is not that different. So this comparison really allows us to see that RSC is not this super confusing thing that no one will be able to understand, as some developers claim for some reason. No, it is actually basically the same rendering process, but split up between two different environments, with the RSC payload bridging the gap between server and client. Now, to finish, just two more observations. First, these steps are not as sequential and as blocking as it may appear from this diagram. So actually, one step doesn't really wait for the other one to finish. Instead, completed render work on the server is streamed to the client right away and integrated seamlessly into the tree on the client over time. So this makes the whole process a lot more fluid and faster for the user. And the second thing I wanted to do is to come back to the initial idea that UI is a function of both data and state. That was the whole starting point of this entire conversation about RSC. Remember? But anyway, and this is gonna be really nerdy, but I think interesting, this way of describing how a UI is generated is actually not 100% correct based on what we learned here. So UI is not a function of data and UI state at the same time, which is essentially what this function implies. Instead, given this two-step process, UI is first a function of data and only then, later, of UI state. Or in other words, data is the input of the hypothetical function and state is the input of the function that is returned from that first step. Now, of course, this doesn't really matter for you, but I like these kinds of more accurate representations of reality and just wanted to share that here quickly. But with that being said, I think we now have a pretty good idea of how React renders components in the RSC architecture and how all the details work behind the scenes. All that's left to do is to understand how server-side rendering fits into this picture. And so let's do that after a quick break in the next video. So, to finish our deep understanding of React server components, let's now bring the concept of server-side rendering in Next.js back into the picture, because it's actually somewhat related to the idea of React server components. So server-side rendering and React server components are not the same thing, but they do interact with each other, and in this lecture, we're gonna find out how. And let's once again start with a quick refresh of the basics, this time of the basics of server-side rendering, or SSR for short. And here we're actually talking about SSR at runtime, so where HTML is generated for each incoming request, which is also called dynamic SSR. But anyway, when we want to render HTML from a React app on the server, we start, as always, from a component tree. This tree will then be rendered to the virtual DOM, which we'll skip here, and from there to HTML, ready to be shipped to the client, so to the user's browser. So, in essence, we can say that SSR means just take this React component tree, render it as HTML, and send that HTML to the browser. Now, besides that HTML, the React bundle, which contains React itself plus the component tree, will also need to be sent to the browser so that the HTML can then be hydrated. And remember how hydration simply means adding back the interactivity to the HTML, so that in the end, we have not just a plain static website, but actually an interactive React app. It's an app like any other React application, with the only difference that the DOM has been generated on the server and not the client. And so we can summarize this step as also send the React code to make the HTML interactive again. So that's the bare bones fundamentals of server-side rendering, so that now we can ask the question, what about RSC? So how does server-side rendering work when we're using React server components? Well, first of all, let's establish that RSC is not the same thing as server-side rendering. In fact, they are completely different and separate technologies. So the goal of React server components is not to replace SSR, but to complement it, so to work together with it. So since both technologies have the word server in them, it makes sense that they can and should be combined. And in practice, as we already know, this needs to be done by a framework like Next.js, which is the one we're learning right now. So when a framework combines server-side rendering with React server components, SSR works in the exact same way as described in the previous slide, as if we were using traditional React without server components at all. This means that both server components and client components are initially rendered on the server when we're using server-side rendering with React server components. But wait, that sounds very strange, right? Why would client components also be rendered on the server? Isn't the server only for server components? Well, those are all excellent questions, and so now it's time to clear the biggest confusion that people have with React server components. So, to start, let's bring back our diagram of how rendering works in RSC. And immediately we can notice that both the server part and the client part are being executed right here on the server. But that's no problem at all, because these are not necessarily the web server and web browser client in the traditional sense. And so here lies the big confusion that many React developers have. They think that the server in server-side rendering and the server in React server component are the exact same thing. However, they are not. They can be the same thing, but they don't have to be. That's why I marked them here with the React icon. So the React server and React client are simply two different environments, two different parts of the RSC protocol, so of this entire architecture. The React server doesn't even need to be an actual web server. In the RSC model, a server is just a computer different from the browser. So a computer that the developer has access to and can run code on. This means that, in theory, React server components don't actually require a running web server. Instead, server and client components could just be rendered once at build time in a process that we call static site generation. The developer could even read files from their own file system during this process because they are on their own computer, or in other words, on the React server. But again, that's just in theory, because usually RSC is indeed coupled with SSR, as we're describing in this slide. I just wanted to quickly make the point that a traditional web server is not required. Now, in a similar spirit, the React client also doesn't need to be a traditional web browser. The React client is simply the part of the protocol that basically consumes the rendered React app. And in the case of server-side rendering, that consuming means to render the app not as DOM elements, but as HTML. And so let's replace that here in our diagram. Okay, so just to quickly summarize this point, SSR works just like before without server components. SSR is still just take the entire component tree render it as HTML, and then send it to the browser. The difference is that now both client and server components are rendered on the web server that Next.js provides in the two different environments on the React Server Components protocol, the React Server and the React Client. Both of these environments run on the server on the initial render, and therefore the output is not DOM nodes but HTML, which is then sent to the browser as always. And if we think about this, it makes sense that client components are also rendered on the server on the first render, because before React Server Components even existed, all components were basically client components, and they would all render on the server during server-side rendering, right? And so it makes sense that the same continues to happen now with RSC in place. So server-side rendering will still simply render all components on the server on the initial render. Okay, and with all that knowledge, we can abstract this idea of React Server and React Client away now and just end up with a diagram that's very similar to what we had initially. It's simply the entire component tree being rendered to HTML and shipped off to the browser. Now, after the HTML has been sent, the React bundle also needs to be sent, just like we saw before. This will contain the React library itself, plus the components code, so that components can later be rendered or hydrated on the client. Now, in practice, since there is streaming and code splitting involved, these will be many different chunks, which will be requested by the client as they become necessary over time. Finally, as we learned in the previous lecture, rendering the server components produces the RSC payload, which contains not only the rendered server components, but also props that have been passed from server to client components, plus for each client component, the URL that corresponds to one of the chunks that we just talked about. And of course, that entire payload is also sent to the client, so that React has access to the entire component tree, including server components and not just the HTML. And this is once again exactly what we discussed in the previous video, where you also learned that this is important in order to preserve state in the browser as server components get re-rendered later. The RSC payload is also necessary together with the React bundle or chunks to hydrate the HTML, so to make the HTML interactive again. Now, since only client components are interactive, of course, only client components get hydrated. Okay, and then from there on, we have a normal React app in our browser, but one that follows the RSC architecture and behaves as we studied in earlier lectures. So, server-side rendering is only relevant for the initial render, and so after that, RSC works just as we learned before. So, after the initial render, the React server is actually the same as the web server where Next.js is running, and the React client is the same as the user's browser. So then, whenever a server component gets re-rendered, a new RSC payload is generated and sent to the client, so to the actual user's browser, ready to be merged into the already existing React tree. And so this way, the existing UI state can always be preserved. Alright, now if you got your head spinning with all this, don't worry. The good news is that you don't need to know any of this in order to use server components in Next.js. The only thing that you really do need to know from this video is that both client and server components are executed on the server on the initial server-side render. But from there on, as the app is interactive in the browser, server components only run on the actual web server and client components only run on the actual client, so the actual web browser. Okay, So feel free to take a break now after these 2 pretty complicated lectures to make sure to digest everything. And then, once you're done, we're now ready to really start working on the Wild Oasis website. So I hope to see you soon in the next section.